Hello students, welcome to this session. In this session we will discuss about an important topic from the chapter electricity, that is electric potential and potential difference. Student, before starting the electric potential, let's know about electric field. Electric field. What is an electric field actually? You know that if I will keep a electric charged object, for example this is a charged object, you see, if I will keep one charged object and let Q is the charged object, and the space or the region around this, the space or the region around the charged object, because this is a two-dimensional board, so I am showing you the area. Actually it is the space around the charged object where or inside which it can exert a force if any other charged object is kept inside this area. Means I can define the electric field is like that it is the space or region around an charged object inside which a force would be exerted on other charged objects. It means this is a charged object and the space around it inside which it would exert a force on other charged objects. It means, for example, this is the charged object, and if I will bring the charged object here, so another charged object is here. So if I am keeping it here, there is no forces applied on this, but when it is kept inside it, then it gives force on it. When I will bring the object, say a small charge object Q is placed inside this area, then it can give the force on it. So this area around this charged object can be called as electric field. So the area or the space around the charged object in which it would exert force on other charged object is called its electric field. So if it is a larger amount of charge, it will have a larger electric field. For example, if the amount of electric charge is small, then it would have a smaller electric field. So the extent of electric field depends on the amount of charge. So a large amount of charge has larger electric field, a small amount of charged object has smaller electric field. Okay, this is the concept of electric field. Then we will read about electric potential. Students, here you see, we will discuss this one. So this is a charged object and this is the electric field of this charged object. So as I have told, if I bring a small electric charged object from outside the field to inside the field to this point, say this point is A. If I will bring this charged object here, this point is A, then what will happen? I have to do some work, because whenever it is enter inside the electric field, then it will give definitely a force on this, and to move the electric charge from outside the field to inside the field, I have to do some work, and the amount of work done in moving the charge from this point to this point inside the electric field is termed as electric potential. So electric potential means how much work is done in moving that charge or a small unit charge from outside to inside the magnetic field. So as I told, the boundary of this electric field is not definite, because a larger amount of charge has large field, a smaller charge particle has small electric field. That's why we define the electric potential as that the amount of work done in moving a unit charge from infinity. Why I am telling infinity? Because the last point of this boundary we cannot sure about it, how much extent the boundary will be there. So we are taking from infinity to a point inside the electric field is called electric potential of that point. It means every point in the electric field has certain electric potential. So as I have told, this point is A. So whatever the amount of work is done in bringing the unit charge from infinity to point A will be the electric potential of A. And electric potential, to measure electric potential, we use some unit, and the SI unit of electric potential is volt. We use the symbol V, and volt is named after the scientist Alexandro Volta. As I told before, most of the units used in physics is named with some name of the scientist. So volt, the unit volt was named after the name of the scientist is Alexandro Volta. So volt is the SI unit of electric potential. So let the electric potential of point A is, so as I have told, the amount of work done in bringing the unit charge from infinity to this point is termed as electric potential. Let this is 2 volt. Okay. Now, if take another point. We'll take another point, that is B. It means now I will bring the same charge Q to this point B. And the amount of work done in bringing the unit charge from infinity to point B, say it is 5 volt, or if you will write shortly, it is V, 5V, and it is 2V. 2 volt is the electric potential of A and 5 volt is electric potential of B. Then if we will take the other term, that is potential difference. What will be the potential difference? Potential difference mathematically is the difference in electric potential of these 2 points. If we will find out the difference of electric potential between point A and B, that answer will be the potential difference of these 2 points. Means if you subtract 5 volt minus 2 volt, so I can write here that potential difference of AB in this case will be 5 volt minus 2 volt, 3 volt. Simply the mathematically you can calculate it. It means difference of electric potential of 2 points in an electric field can be termed as potential difference. But now how can you define it in terms of work done? So here we are defining electric potential difference in terms of work done. So what I can write, that the potential difference between 2 points in an electric field is the amount of work done in moving a unit charge from one point to other. You see, I have told two definitions. The difference in electric potential of 2 points is termed as potential difference. Like I have told, I have subtracted the electric potential of these two, then I can get potential difference. But how can you define in terms of work done? Then what you will do, write the potential difference between these 2 points in an electric field is the amount of work done in bringing or in moving a unit charge from one point to another. It means if this is a point, if you want to find out the potential difference between A and B, then the amount of work done in bringing a unit charge from A point to B point, that much work done will be the potential difference of these 2 points. So I have written the potential difference between 2 points in an electric field is the amount of work done in bringing a unit charge from one point to another. So if you write mathematically, then I can write in this way that potential difference equal to work done divided by quantity of charge moved. How much charge you have moved. If you divide the work done divided by the amount of quantity of charge moved, then you will get potential difference. We can write mathematically. So students, as I have told, the potential, electric potential, the SI unit of electric potential is volt. So definitely the SI unit of potential difference, I am writing shortly PD, is also volt, because it is the difference in potential, hence its SI unit will also volt. Okay. Now we have discussed the potential difference in terms of electric field. Then how can you apply this potential difference in an electric circuit? Practically, how can we apply the potential difference? Okay, you see, we will take one example now. Let two tank is there. Okay, here are two tanks with water and a horizontal tube is there. So let the amount of water, same amount of water, then what will happen? Is the water will move from one tank to another? Definitely not. The water will remains constant. It will not move from one tank to another because they have the same level. But if I will make one of the tank has more water level, or level of water will be more, so definitely the water will move from this tank to this tank. Why? Because this tank or the water present in this tank has higher pressure and it has low or lower pressure, and water will move from higher pressure to lower pressure till the level or the pressure will be same. So water will move only when there is a difference in pressure. From higher pressure to lower pressure, then the water will move in the tube. If both have same pressure, then water will not move. So if we apply like this, as I have told that current, we have discussed about it, current is flow of charge. So if we take a conductor, let it is a conductor. So inside the conductor or electric wire, the charge is present, but the charges or the electron will not flow inside a wire if there is no difference in electric pressure between the 2 points. It means this is A point and this is B point. If these 2 points have the same electric pressure, that we call physics in term, that is electric potential. If a same electric potential is there between the two ends, then the electron will not flow, the charge will not flow, so there will be no current. For example, you see here one wire is there, okay, and it is an electric wire, and this wire has electron inside it, but is there any existence of current? Is current is flowing in this conductor? Definitely not. Why? Because these two ends of the conductor has same electric potential. There is no difference in electric potential. That is why the charge or electron will not flow. But when this wire is connected to a cell, if the conductor is connected to a cell, definitely the current will certainly start to flow from positive to negative, because this cell is maintaining the potential difference between two ends of a conductor. You know, this is a cell. So as I have told, there is no current is there. But when I will join the two end of the conductor to between the two terminals of the cell, definitely the current will flow in this wire or conductor. So if I will connect here one bulb, so definitely the bulb will glow because the current is flowing through it. So if I will take out the wire, you see, this is the cell and it has two terminals. This one is the positive terminal and this is negative terminal. So between these two terminals, actually there is a potential difference of 1.5 volt. You know, this cell we normally call as pencil cell. This cell has 1.5 potential difference between these two ends. The positive end has higher electric potential, we take, and negative end has lower electric potential. And if you will make the difference between these two ends, then it will be 1.5 volt. How this actually this cell maintain the potential difference of electric circuit. So whenever you will join an electric circuit with a cell or battery, then only current starts to flow, because the cell maintains the potential difference. Actually inside the cell some chemical energy stored inside it, and that chemical energy is used to maintain the potential difference. So different type of cell or battery are there. Some have 6 volt battery, they maintain 6 volt potential difference between positive and negative terminal. So what I want to say to you, that it is the cell or battery which maintain the potential difference in an electric circuit. Then this electric potential difference in electric potential, if you will define in the terms of electric circuit, then I can say the amount of work done in moving a unit charge from one point to another point in an electric circuit is called potential difference between these 2 points. So you can define in terms of electric circuit. So the potential difference between A and B will be the amount of work done in moving a unit charge from A to B. And you know, to move the charge from A to B, a cell must be connected with it, and this cell maintain the potential difference between A and B. And if we define this, so as I have told that potential difference will be the work done divided by quantity of charge moved. So if you will write in terms of symbol, then I can write V equal to W by Q. So this will be the formula. V equal to W by Q. V is the potential difference, W is the amount of work done, Q is the quantity of charge moved. And hence, if you write in terms of unit, so I can say hence 1 volt equal to 1 joule by 1 coulomb. I am writing the SI unit of V, W and Q. So 1 volt equal to 1 joule by 1 coulomb. And if you want to define 1 volt, then you have to write one sentence using this formula. So I can define 1 volt like this, that if 1 joule work is done in moving 1 coulomb charge from one point to another in an electric circuit, then the potential difference between these points will be 1 volt. If 1 joule work is done in moving 1 coulomb charge from one point to another in an electric circuit, then the potential difference between these points will be 1 volt. In this way you can define 1 volt. And another point is that the potential difference is also termed as, the potential difference is also known as voltage. You know that we normally in our daily life you use the word voltage, that today there is less voltage because hence the fan is not moving properly. So voltage means potential difference. It means the potential, if voltage is less, it means the potential difference is less in a circuit. You know, in your house there is also a circuit. Actually the potential difference between 2 points, in any 2 points in the electric circuit of your house, is 220 volt. Remember student, 220 volt potential difference is maintained by the power department. and all the instrument in our house, all the electrical instrument, they work with the potential difference 220 volt. When the potential difference is 220 volt, they work effectively. But simply one cell has the potential difference of 1.5 volt. Okay, so the potential difference to, how can you measure this potential difference? So there is an instrument called voltmeter. So what is voltmeter? It is an instrument which is used to measure potential difference or voltage. So if you want to measure the potential difference or voltage between 2 points, then we use voltmeter. Students, you know, they in your fridge or other instrument, we use one stabilizer. In stabilizer, if you find there is a voltmeter which written as V. The voltmeter is present in that instrument, and that voltmeter actually shows how much potential difference is there in the circuit. So voltmeter is the instrument which can measure the potential difference. Okay students, so we have discussed about the electric potential and potential difference. So I think you have understand this topic. So we will discuss another important topic of the chapter electricity in the next session. Till then, bye bye.